Okay, so proceed tayo rito sa number 3. We have here the constant volume and the constant pressure specific heats. So these are the heats. Now, in this case, we are talking about the heat transfer of the system. Okay? Considering that the volume is constant or the pressure is constant. Okay? Ibig sabihin nito, we are letting the transfer of energy by transfer or we are letting the transfer of heat, okay, using the change of temperature with respect to the constant with respect to the pressure if the volume is constant, or with respect to the uh, volume if the pressure is constant. Okay, so yun, so we are actually finding that value by using this equation here. Okay, itong equation 3.29 for constant volume or constant specific volume, and then this CP or equation 3.30, okay, for constant pressure. Okay, so as you can see here, they are all with respect to temperature kasi we are assuming here that the specific heat or the transfer of heat is due to our change of temperature, no? Siyempre, no? Pag meron tayong change of temperature, so siyempre meron din tayong transfer of heat. Okay? So yun. So this would be the simplification, no? For this kasi, for this specific heat at constant volume at saka constant pressure, minsan nangyayari 'to siya sa mga object in which it has a lower density. Okay, so lower density. So 'pag lower density ka kasi, okay, um, just like for gases, okay? So just like for gases, we can the relationship between the temperature and the specific heat is defined by this equation 3.29 and 3.30. Okay? So for this special case naman for solids and liquids, okay? The specific heat is also defined, but instead, okay, we have here dH is equals to du plus dPV, or approximately equals to du plus VdV, assuming that our specific volume is constant. Okay, so yun. So we have here CDT, no? Same pa rin for solid, but for this case kasi, for solid and liquid, we have a constant specific volume. Okay? So, yun yung pinagkaiba. Oh, same for our H2 and minus H1, no? We have here constant specific volume C. Okay? As relation or in relation to our T2 at saka T1. Okay? Or DT. Based on this one here. Okay? So, basahin lang natin to siya. Okay? So, yun. So, for ideal gas naman, we know that ideal gas have totally lower density, no? We can actually apply that concept, no? We can actually apply that concept na yung internal energy natin at saka yung internal energy natin at saka yung enthalpy natin are all function of temperature. We can actually apply that one dito sa ideal gas natin, since in ideal gas our specific volume is constant. Okay? I mean our density is probably neglectable. Okay? So yun. So we have here PV is equals to RT, or we have U is equals to F of T. Okay? So yun. Internal energy daw is a function of temperature. Then we can actually derive this formula na CV is equals to partial of U over partial of T at constant specific volume. Okay? So yun. So we have here CV sub O is equals to D over dt. Okay? Then of course, okay, so yun. This the final equation here would be this H is equals to U plus PV, or it is since yung PV natin for ideal gas, PV is equals to RT. So we can actually express this U plus PV, equation 3.37, into U plus RT. Okay? So therefore, as you can see here, no, na-prove natin that for ideal gas, the enthalpy is a function of temperature, okay? As we have already said here dito sa equation number 3.20 3.30, okay? Dito. Okay? Enthalpy is a function of temperature, okay? So yun. Okay. For same for our constant pressure naman, no? We know that specific heat at constant pressure is equals to change of enthalpy over change of temperature. Okay? So, if you use the definition na Cp sub O is equals to dH over dt, then substitute natin yung Cp sub O or gawin natin yung internal energy enthalpy natin as a uh, enthalpy, 'no? At saka yung dt natin is gawin nating yung specific heat natin is gawin nating heat to multiply it by mass, which is this equation 3.40. Then for that case, makukuha natin that our Cv sub O or Cp sub O is also a function of temperature. Okay? So yun. So as you can see here, itong graph niya, no? Kumbaga, okay, yung dalawa, no? Kung meron tayong dalawang cases or constant na temperature at saka kung meron tayong dalawang graph in which a variation of temperature, assuming that the enthalpy and the internal energy are all constant, we can actually find the value, or we can actually relate the value from these two, or between these two uh, temperature, variation of temperature, by late or by letting the movement from this point 1 or point 1 to point 2, or point 1 to point 2 prime, or point 1 to point 2 double prime. So ibig sabihin, pwedeng tatlo yung path mo for you to be able to find the change of temperature between these two variation of temperature. Okay? So yun. So ibig sabihin nun, Cp sub O, Cv sub O are all function of temperature of given that constant pressure at saka constant volume yung kuan mo. At saka given then that our density or our density is lower. Okay? Yun. So, okay. So, pakibasa rin din to. Derivation lang to siya ng Cp sub O in molar basis. Okay? So, yun. So, dito tayo sa example number 1. Okay. So, basahin lang natin. Okay. So, sige. I-discuss natin to kasi importante to, no? Example number 1. I mean example number 5. We have here, calculate the change of enthalpy of 1 kilogram of oxygen that is heated from 300 to 1,500 Kelvin. Assume the ideal gas behavior. So, ibig sabihin nun, uh, we can actually apply what we have already derived kanina, that Cp sub O and Cv sub O are all function of temperature, and internal energy and enthalpy are also function of temperature. Okay? So yun. So solution, we have here for an ideal gas, the enthalpy change is given by equation 3.39. Okay? Saan yung 3.39? Okay, so ito, no? The change of enthalpy is given by this Cp sub O dt. Okay? So yun. So the change of enthalpy is a function of temperature from equation 3.39. However, we also need to make an assumption about the dependency of a specific heat on temperature. Siyempre, no? Since yung specific heat natin is nag-change yan siya, or na-accumulate yan siya due to change of temperature. Okay, so let us solve for this problem in several ways and compute the answers. Now, our most accurate answer for the ideal gas enthalpy change for oxygen between 300 to 1,500 Kelvin would be from the ideal gas table. Okay? So, yung ideal gas table na yun is from table A.8. Kung sino man sa inyong may kopya ng libro na ginagamit natin, no? Pakitingnan na lang yung table A.8, no? So, nandoon to siya. Yung wala naman, pwede kayong kumuha sa akin, or pwede kayong kumuha sa iba, okay? Sa mga classmate natin, okay? Classmate niyo. So, this result is using equation 3.45. Okay? Doon sa table A.8. Um, the empirical equation from table A.6 naman, okay, actually, this result here na H2 minus H1 is from equation 3.45. Okay? But if we have to use the empirical equation from table A.6 naman, we have dapat the same yung makukuha natin na value ng H2 minus H1. Okay? So, The equation from table 8.6, empirical equation is given as this one, no? We have here H2 minus H1 is equals to integral of Cp sub O dt from T1 to T2, okay? Or equal siya sa, papalitan natin yung limit ng theta 1 at saka theta 2. Tapos yung Cp sub O is papalitan natin siya ng expression in which if we have to derive that one, I mean if we have to integrate that one, ang result is ito. Okay? So 0.88 theta tapos 0.001 over 2, no? So yun, ito yung result natin. Yung 1,000 dito, nagmula to siya doon sa sa equation natin sa table A.6, no? Pag yung dt natin is papalitan natin ng change of theta, okay? Dapat yung change of theta na yun is naka-multiply ng 1,000 based on that table A.6, okay? So yun, so if we integrate this one here, so we have here, okay, the result, then ipapalit natin yung limit. Itong limit din na to, makukuha din natin to sa table 8.6. Okay? Pakitingnan na lang din. Then after that, yun, makukuha na natin yung value, final value, which is 1241.5 kilojoule per kilogram. As you can see here, maliit lang yung pinagkaiba nila. Okay, based dito sa dalawang method na to, maliit lang yung pinagkaiba. So, pwede, no? Kahit saan dito, pwede mong gamitin. Okay, which is lower than, okay, so 2% lang yung pinagkaiba nila. Okay, so if we assume a constant specific heat naman, we must be connected about what the value we are going to use. If we use the value of 300 Kelvin from table 8.5 as we found, or as we find from equation 3.44, that H2 minus H1, no? Ibig sabihin yung CP sub O is makakita natin yun siya sa table 8.5. Okay? So, yun. Mahanap na natin yung H2 minus H1, which is 1106.4 kilojoule per kilogram. This 1106.4 kilojoule per kilogram is due to the change of uh, of or due to the specific heat, okay, uh, uh, which is constant specific heat. Okay, so yun. So, yun, no? So, yun, basahin lang natin to siya. Pare-parehas lang naman yun siya ng solusyon, no? Ito siya, kinuha lang yung H2, no? Or kinuha lang yung change of enthalpy, H2 minus H1 here, okay? By using this one here, yung CP sub O na nakalculate natin from table 8.6, okay? Then, minultiply natin siya sa value ng ating ng value ng change of temperature. Okay? So, yun, 1,200. Okay? So, yun, 1,200. Ito, 1,200. Okay? So, yun. So, yun. So, ibig sabihin nito, by using this table, different table here, we can find the change of enthalpy, okay, in different ways. Okay? Pwedeng ganito, pwede rin ganito, pwede rin ganito, pwede rin dito sa part na to. Okay? So, yun. So, same for example number 6. Okay, for example number 6, this is just the application of an ideal gas, no, in relation to the constant volume or specific volume at saka constant pressure. Okay, we have here CV sub O at saka CP sub O. Okay, so yun. So if you have any question about these topics, you may just have to ask it to me. I hope no this video lecture serves as your guide, okay, enough guide to fully understand what we have saying here. Okay, so once again, if you have any question, kindly ask it to me. Assalamu alaikum warahmatullahi wabarakatuh.